Hello. Hello and welcome to this video. In this video, we will talk about exceptions and how we can use exceptions to write programs which are clear in intention and in general how to use exceptions. So if you have programmed in C, then you would know that when there is an error, you have to send some sort of code or some sort of value to the caller. For example, let me show you. Okay. So, for example, if you have a simple function like printf, okay, and the printf, if you see this, you see the printf family of functions all return an integer. So, irrespective of what the significance is, it tells something about what happened in the code. Okay. And then there are functions which are void, which do not return anything. So they don't tell anything about what happened in the code. Okay. For example, you can also look at malloc. So malloc definitely returns a void pointer. Malloc family of functions return a void pointer, while free does not return anything. Okay. So similarly in C++, you can use error codes just like C, and you can also use exceptions, or you can mix both of them. You can use both exceptions as well as error codes. Now, as I said in the last video, exceptions should be thrown in exceptional cases, not when an error happens. You have to make a distinction between exception and error. Okay? Exception is something which you can handle and the program can continue. But error is something with which the program cannot continue. It is an error. Now we can't proceed. There is no way to fix this problem. I'll give you an example, okay? Suppose you are writing a web server or a database server, okay? And you try to bind to a certain port, particularly ports less than 1024. But what could happen is that the program was launched as a normal user, not as a root or administrator. And then you are not allowed to bind to that port. Now, if you cannot bind to that port, the client cannot access the main database server, or the web server cannot be reached by browsers. So there is no way for the program to recover from this situation. So what you can do is you can throw an exception, and while handling the exception, you print a message and bail out. That is one way of doing it. The second way is that you treat this as an error and return an error code which will be eventually returned to the program which spawned the web server or the database. So both is are valid. The problem with exceptions is that there are two problems with exceptions. One is that exceptions can be buried deep inside inheritance hierarchy. Now, when that happens, tracing exception becomes pain in the butt. Okay. The second problem which happens is that you can place the exception. Well, one of the problems is that exception itself is an object, so it is quite heavy compared to a simple integer. The second thing which can happen is you can place a lot of stuff inside exception and you put them on heap, which is kind of a misuse of exception object. Okay. In general, exception objects should be very simple, and in ideal situation, they should not put anything on heap. Okay. It should be a plain object, plain data object it should be. So we'll see what are the best practices with exceptions. In earlier days, what used to happen is that coding guidelines, for example, I remember coding guidelines of Google, they strictly ban the exception uses in the program. You have to just use return codes. That is simplistic way of looking at how the program should be written, and it is quite valid. Okay, when you need maximum performance, you don't want to deal with exceptions at all, and I accept that kind of coding standard. But then I also accept the kind of standard where you use exception. Okay, I can accept both the arguments that exceptions make code cleaner, it is well designed and all that. So you can sacrifice a bit of performance, and uh, we have already discussed one of the problems which we have with exceptions, how to fix that. And that is not to use inheritance. For example, languages like Rust, they do not have inheritance. As far as I know, Golang does not have inheritance. They fix it by using composition. If you want to achieve the effect of inheritance, use polymer traits and composition in Rust, and that's how you can fix the problem of object orientation. So let's look at this program which I have created for you. We have a class logger which takes the name of the logger, and it's a RAI class. Okay, so RAI means resource acquisition is initialization, and when you release the resource, it is deallocation. So in this class, we don't have anything dynamic. We take the constructor takes an argument and moves that string to the name, and move the name to the name data member, and prints constructing name, and then the destructor says destroying name. Then we have application error, which we have got from exception class. This exception class is part of exception. Then we have to be except header for certain built-in header. And this one has a what number function, which returns a const char pointer. And this function is const. That means it does not modify anything past to it. No except means it does not. It is guaranteed not to throw an exception. And override means it can be overridden. And the message which what prints is generic application error. Then we have database error, which derives from application error. And now the what string which it will return becomes database connection failed. And this also throws no exception. Then we have network error, which says network available. Then we have more exception classes, divide by 0, inherited from exception, and it prints division by 0. Then we have a function, throw integer, which throws an integer. Then we have a division function, which is division by, which can throw division by 0 error exception, which we have defined earlier. So this divide by 0 exception will be thrown by this particular case. Then we have standard exception of runtime error from std except. You try to open a file, you are given a file name, you try to open it, and if you can't open it, then you throw a runtime error, unable to open file. Then we have allocate memory, which tries to allocate large amount of memory, and when it says memory allocation failed, let me see, it might be allocated for my system 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 gigs, it might succeed, okay? We need to put more 0. Okay, and this is a bad alloc exception, which is an inbuilt exception. Then we have a connect database function, which stores database error, connect network function, which stores network error. We have a level 3 function, which creates a logger of constructor named level 3, and it shows a runtime error occurred in level 3. Then we have level 2 constructor for log, and it calls level 3. Then we have level 1, which calls level 2. So what this essentially means, if we call level 1, it will call level 2, and which will call level 3, and then eventually runtime error will be shown. Then we have a throw example. We try to divide by 0, and you catch an exception, and you throw again. Then we have nested exception. Try to open file, you catch, and then you throw with nested, runtime error. And then we have print nested. So we receive an exception in this, and we print e dot what and rethrow if nested, and then we have print nested. Okay. Then we have save function no except, which does not throw an error, which does not throw an exception. Now we first call throw integer and we catch it. Okay. Then we have divide by zero problem. We catch it again. If you don't catch an exception, it program will be terminated. The behavior is same in Python or Java or C++. I think in Java, if it is not a runtime error, that is system runtime error, then you have to catch it mandatorily. Okay, Java does not allow you to skip the exception catching. You try to open a file abc.txt, and then we have runtime error and so on. Then we have allocate memory, connect database, connect network, and now you see here connect database. We first try to catch database error. Okay, so this, if there is an exception hierarchy of classes in terms of inheritance, then you should try to catch the derived error first and the parent class or superclass or base class exception that should be towards the bottom. So it should be in the reverse order of inheritance, because base class application error will catch database error, but database error will not catch application error. So it is not mutually exclusive. And similarly, we have level 1 exception and we throw example. Then we have nested exception and we finish. So first we run this program and then we will look at the best practices. So let me quickly launch the shell, fancy term. I don't want fish, I want bash. So we say g++ minus wall minus w error minus std is equal to c++26 minus pedantic. And then we call it except.cpp. Command line w error. Okay, w error. We have a typing mistake. So it compiles cleanly, and then we run that, and we have the problem. You see bad alloc came here. Okay, it was unable to open file adc.txt, and all the expected stuff came. Now, when the logger situation, you see how the loggers were created and destroyed, and the exception was caught in level 3. We have rethrow example, division by 0. We have nested up exceptions, we have no except, and so on. So we can use this program, you can type in, or maybe I'll make a gist out of it, and I'll put it in the description. Okay, I'll create a gist out of it and I'll put it in the YouTube stuff. So some best practices are there. You should throw exception objects, not pointers. Catch exceptions by const reference to avoid slashing and unnecessary copies. Derive custom exceptions from a std exception or one of its subclasses and override that. Override what? Use exceptions for exceptional condition, not for normal control flow. Prefer ISO resources are released automatically during stack unwinding. Preserve the original exception with throw with rethrowing inside a catch block. Mark functions no except only when they truly cannot allow exceptions to stay. Now, there could be a situation where exceptions are problematic. Okay, now let me give you an example. Suppose let's look at this divide code. Okay, now assume that here you do some memory allocation. Okay, and you release it here. You free in C terms free it. Right. Now, if this exception is caught, what happens to this memory? We don't want that. Okay. So the best ways, which we have already discussed, is try not to use raw pointers. Make use of unique PTR, shared PTR, weak PTR. They make your life a lot better. Okay. Then we have another best practice. Preserve the original exception with throw when we throwing inside a catch block. Mark functions no except only when they truly cannot allow exceptions to stay. Okay. So with this, we come to the end of this video, and I hope that we have covered exceptions in some detail. So this entire program and the best practices I will put in a gist, and the link will be in the description. Let me do it right away. So we go to gist.github.com and we create a new gist. Okay. It was a bit slow. We put this here and we mark this CPP and bring down. That's it. And we create a public gist. A public gist. And there we go. We have the gist. I don't know why it didn't highlight the syntax. It should have highlighted it. Anyway, so we don't care about it. At least I don't care about it syntax highlighting. Oh, it says it as gist file.text. That is why it created problem. Okay. So what we do is we need to we'll delete this and create a new one. Okay, and we create a new gist, and how do we give the name? Add file? No, we don't want to add file. We want it to be a markdown stuff. Copy, Control V, and I'm not very familiar with this exceptions. You see, file name is here about exceptions dot undo in C++. Okay. Now some may argue this should be capital letter. Exceptions dot undo and create public gist. Okay, now we have syntax highlighting. Very nice. All right. So with this, I will end this video here, and I hope that you have enjoyed this video and learned something about exceptions. So we'll meet again in 4 days, and we will talk about, I believe, one of the less talked about aspects in C++. That is, we will talk about input output. In particular, we are going to talk about input stream and output stream, IF stream, OF stream, and all that we'll talk about. Or maybe input output we can discuss later. So let me think. I might introduce templates. Okay, that is a very tempting topic for me to discuss. So we can discuss templates and how the programming works in C++ in general. Or maybe we can introduce more language features, but I don't want to introduce more language features right now. We'll just discuss the templates to start with, and then we can go left and right and see what we can discuss. So thanks a lot for watching the video, and this gist will be in the description of the PDF of the YouTube video, and you are most welcome to edit it and suggest editing. So thanks a lot for watching, and I'll see you in the next one. Have a nice day and enjoy.